Welcome back to the Lava Academy podcast. I'm your host, Iain MacKinnon, a former primary school teacher from Scotland, now living in Reykjavik and playing with lava for a living. And I am joined by my co-host and my boss, Ragnhildur Ágústsdóttir.
Yeah, hi. Hi, everyone. So fun to be here, as always.
Yes, indeed. And we have got a fantastic interview this month. Really excited for you all to hear this interview. And so I think we will just jump straight over to that right now.
Yeah.
Okay, so we're joined today by Sævar Helgi Bragason, who is, well, lots of things, apparently. A lecturer, a writer, a science communicator at the Natural Science Museum in Kópavogur. Sævar, welcome to the podcast.
Thank you so much.
And so tell us a little bit about yourself, kind of a bit about your background and kind of what you're doing now.
Sure thing. Well, I have a background in geology, but I have never ever worked in geology. I've only worked in astronomy, teaching astronomy at the high school level, also in partly in like university level. Mm-hmm. So I'm much more of an astronomer than I'm ever a geologist. And I try to go out every clear night to look at the stars or the northern lights. I have a very, very tiny company called Iceland at Night that's trying to service tourists that travel to Iceland to chase the northern lights and dark skies.
Yeah.
And yeah, that's basically me. I have a wife and 3 children as well. So
woohoo!
Busy house.
I could add so much to this list. I mean, like being part of Krakkarúv and, you know, basically trying to bring news to kids in Iceland. Yeah. So many things.
And let's not forget the books as well.
Oh, yeah.
Oh, yeah.
Right.
Yes, Sævar has written on everything from space travel to poop.
That's right.
Yep. Not even kidding.
For kids, yeah. So I guess I would describe myself as a science communicator. And I'm heavily involved with teaching kids just to appreciate science and get them interested in science. So I've written, I think, about 10 books now. My most recent one is about the Big Bang, and it followed the book about poop. And the poop was actually about the cycle of nutrients in nature and what happens to all the stuff we leave behind when we go to the bathroom. Yeah. And I think it sounded nicer when you call your book Poop, Peas and Fart instead of the cycle of nutrients in nature. You probably want to sell all that well.
But it's when they're calling you a science communicator.
Yeah, that's right. It's just marketing.
No, but I mean, we love, of course, what we are all about is, you know, science communication and trying to make it both interesting and fun.
Yeah.
So, you know, that's why you're here.
Yeah, well, I try my best. So do TV work and frequently on the radio and all that stuff. Yeah. But I keep forgetting things. I was talking to a guy just recently, and he said, "Oh, it's been a while since we met." And I was, "Where did we meet? We made a TV show together." Really? Just can't remember.
Age plays a part in that. I'm with you there.
Yeah.
So yeah, I mean, as Raka was saying, you know, we're obviously we're into volcanoes here, but we're also into kind of education and kind of like telling people all about the kind of science behind all of this stuff. And when I'm doing the shows here, I am often asked all sorts of questions, but one question that keeps coming up, I've had it multiple times, is, are there volcanoes in space? Now, I know the answer to the question is yes, but honestly, that's about as far as my knowledge goes on this matter. So that is why you are here today, to kind of educate us on this. So are volcanoes, are they a rare thing in the solar system and beyond, or is it actually kind of quite common once you start looking for it?
Yeah, so volcanoes are very common in the solar system. Every rocky planet has a volcano or volcanic systems, or multiple volcanoes, such as Mercury. Venus is definitely a volcanic planet. And on Mars, of course, we have the biggest volcanoes in the solar system. We don't know if they're active or not. But also on some moons in the solar systems, there might be cryovolcanoes, erupting slush or slurry type of lava, so cold lava basically. And then you might have some different types of eruptions like geysers on other moons as well. Even on Pluto has evidence of cryovolcanoes. So they're everywhere.
Yeah, we'll step through the planets kind of one by one, I think, you know, later on in this. But what actually makes a planet capable of having volcanic activity in the first place? I mean, what
Well, you need
what do you need?
You need what you are producing here, lava. So you need to be a rocky planet first and foremost.
Okay.
And Mercury, Venus, Earth, Mars, of course, the moon is a rocky place as well. So as long as you melt some of the rocks the planet is made out of, you usually end up with some volcanoes. And they usually were active maybe billions of years ago, maybe even recently. For example, Venus might also be quite active still. So you need to melt it somehow. And if you're small, like a small potato or something like that, like Mercury, your volcanic activity has ceased maybe eons ago, while it's keeping going on other planets like Venus, Mars, Earth as well, of course.
So this thing about it having to be a rocky planet, basically, so for the big gas giants that we have, they wouldn't be volcanic themselves, but the surrounding moons.
Exactly right. Maybe. So like Io, the moon of Jupiter, is the most volcanically active body in the solar system. There are more volcanoes there than here, so maybe you do a lava show there.
Easy.
Yeah, easy.
I don't think the plans for expansion go quite that far.
Really. Where's the ambition? But for example, on Io, the volcanoes are hugely impressive. One of the most powerful volcanoes in the solar system is there, called Loki Patera, after the one of the titans in the Nordic mythology, Loki. And it's a giant lava pond, basically. And I mean, Io is a beautiful place. It sort of looks like a pizza with multiple types of cheeses on it and some strange type of pepperoni. But here and there, it's always changing. It's ever changing. And its volcanic activity can be traced to tidal forces within Io itself, because Jupiter is so massive, it's kind of squeezing it back and forth, and it melts the rock within. And you end up with these stunning looking volcanoes.
So wait a second. So the gravitational pull of the planet itself is causing the melting of the rocks in the moon that's orbiting it.
That's exactly right.
Whoa.
Yeah. So and on other moons around Jupiter, like Europa. So Europa is an icy moon. It has an icy crust or surface, and there might be geysers there. So we have some evidence that there is actually water seeping through some cracks in the surface into space. And if there are, Europa will also feel the tidal forces of Jupiter and the surrounding moons as well. So you might have at least geothermal activity in the bottom of the ocean below the icy crust. So it might be habitable because of that. So who knows?
But I mean, talking about moons.
Yes.
Our moon, I mean, we do have some gravitational pull. Why isn't anything happening there? Well, what's the reason?
Yeah, our moon is really small compared to, the Earth is not that big, to be honest, and the moon is not, it's fairly big, but the effect is a little less pronounced because Jupiter is so incredibly massive. So Jupiter is about, around 1,300 Earths could fit inside Jupiter easily. So Jupiter has this enormous gravitational field and gravitational pull. So it's just much, much stronger than in the case of our moon and the Earth. But the interior of the Earth definitely feels the gravitational pull of the moon. It's just way less than, for example, at Jupiter.
So one connected question, because like you're talking about the gravitational pull, and I mean, we all know that one thing in the solar system has the most gravitational pull, the sun, right? Yeah. So does it matter how close to the sun a planet is, or a rocky planet or moon is?
Absolutely. It has an effect on if it's just melting, basically. For example, we have found exoplanets that are orbiting so close to their own host sun that they must be molten, and they must have very frequent volcanic eruptions everywhere because of such strong tidal forces just melting the interior constantly. And those are way closer.
I'm still trying to wrap my head around this, because this is something I'd never, ever, ever thought of, that gravity could actually be melting.
Yeah, it can definitely. Yeah, so it's basically just tidal forces, and tidal forces basically squeeze. So if you fell into a black hole, the black hole would pull your head stronger, or your legs, depending on which way you fall into it, with stronger than your feet, and you would be stretched because of tidal forces.
Very briefly.
Yeah, exactly. You would be turned into spaghetti. And that's the thing. You are orbiting some very strong gravitational pull, like a star. And if you're very close to it, you feel the pull much stronger than if you're further away from it. So it has a larger effect on you. Cool. So in the end, I mean, some of these planets, they orbit their own sun in like 1 day or 2 days or 3 days even. Yeah. While our planet is 1 year, of course. So it's much, much, much closer in. Yeah. But also the sun has its own eruptions.
Yeah, exactly. I wanted to ask about that.
Okay, so are we getting there? Am I getting way
Just
ahead?
go ahead. That's fine.
Any questions we have written down here?
All right.
This goes.
Just fly out the window. But yeah, some of the most impressive eruptions in the solar system is, of course, from the sun. And we just, when we are recording this, Earth is currently being bombarded by solar material from an eruption that happened just yesterday morning.
But these are eruptions in not kind of what we would call an eruption on Earth.
So it's not erupting lava or anything like that.
No.
It's erupting plasma, mostly just electrons throwing into space at extreme speeds. And when it collides with the Earth, we are sometimes lucky enough to experience beautiful northern lights. So that's how they appear.
So technically, you could say that the northern lights are the result of plasma eruptions.
Yes, exactly right.
On the sun.
Yeah. Not technically, they just are.
Yeah. Yeah, not lava eruptions.
Not lava
plasma eruptions.
Plasma eruptions. Yeah, but that's also interesting if we go back to Io around Jupiter. So Io has a weak gravitational pull because Io is small. So the volcanic plumes from Io reach out into space. Mm-hmm. So they can reach maybe 300 kilometers altitude or so. And that's into space. So some of this material gets left around Jupiter, forming a small ring. And that takes part in producing aurora on Jupiter, actually, as well.
Really?
Yes. Cool. So volcanic eruptions on Io can cause aurora on Jupiter.
So the rings that we have around Saturn, do they have anything to do with something like this happening in the moon surrounding them?
Yes, there's one ring around Saturn called the E-ring. And the E-ring is where a small moon called Enceladus is orbiting. And when Cassini spacecraft went into orbit around Saturn in 2005 or 6, it discovered that from Enceladus comes water vapor, just erupting through cracks in the southern hemisphere of that moon, and it's forming one of those rings around Saturn. And funnily enough, it might be a habitable moon, so there might even be bacteria streaming into space from these geysers on Enceladus. But we just hitherto lacked some type of equipment to measure it, actually. So we haven't found any life there so far. But there might be frozen bugs or something like that orbiting Saturn. It's highly unlikely, but who knows?
Fantastic.
Yeah.
Wow. That's so cool.
So let's do a little kind of tour of the solar system. Let's kind
tour of the solar system.
So let's get right up close to the sun. First of all, Mercury. What's going on there?
So Mercury probably doesn't have volcanic activity yet because Mercury is quite small and it probably cooled down eons or billions of years ago. But there are signs of volcanoes there, maybe even caldera and shield volcanoes even. So there are enormous lava fields as well, but probably nothing active right now.
Okay, I want to ask maybe a little bit of a strange or stupid question even. There are no stupid questions.
Stupid questions.
I mean, Mercury is... Oh, you. So, because I feel like it's a little bit contradictory to what we were just talking about like,
the closer you are
to the sun, the more volcanic activity. And then we have Mercury, which is the closest, and we're basically saying nothing is happening there.
Yeah, but Mercury is still very, very far away from the sun. It's like 86 million kilometers or so, something like that, away from the sun. So it's way too far for the sun to have any dramatic effect on its volcanic activity. But it definitely does feel tidal forces. But it's less pronounced than, for example, here on the Earth, because we have another object orbiting us, the moon, and it's much, much closer to us than the sun is from Mercury, so it has much more of an effect on us than the sun has on Mercury.
Okay. So Mercury, not really.
Well, it's a fun planet, definitely, and there are basaltic lava fields there, just like we have here in Iceland, and they are very ancient. Some of the youngest ones are only like 4 billion years old or so, shortly after the formation
Yesterday.
Well, almost, in astronomically speaking.
Yeah,
definitely. But Mercury probably hasn't erupted all that much since then. It may have happened within the last 1 billion or 2 billion years, who knows? But still, most of the lava fields are very ancient.
Okay.
Yeah.
Okay, so stepping
a little bit further
out
up.
a little bit further, we've got Earth's evil twin.
Yes.
Venus.
Yeah, the beautiful Venus, shining usually brightly in the sky. And when you actually look at Venus in the sky, it has this yellowish, whitish color to it. And that's because of volcanoes. So that's sulfuric acid in the clouds of Venus. And that sulfuric acid probably comes from volcanic eruptions on Venus maybe a few 100 million years ago. Because when we look at Venus, it completely almost lacks any craters. And if you have a surface in the solar system that usually don't have any craters, like the Earth does, it means that the surface is young. Something has been replenishing it or resurfacing it.
Okay.
And Venus doesn't have any oceans. It may have had in the past, but we see evidence of huge amount of volcanic or episodic volcanic activity, maybe about 500 to 700 million years ago, that completely resurfaced the surface. So,
wow.
Yeah, and there are huge volcanoes there.
So Venus was basically repaved.
Yeah, exactly right. And the thing is, when you have constant eruptions taking place over millions of years and you lack ocean, slowly you build up carbon dioxide in the atmosphere, and you have what's called a greenhouse effect, or a runaway greenhouse effect, which means that the surface temperature on Venus is around 480 degrees centigrade. And that means that the lava there is still a little bit soft, so it's not really rock hard.
Yeah,
like
it doesn't really get the chance to completely solidify.
Exactly. So yeah, don't go there for a summer holiday.
You would be like bouncing
on a very hot lava.
What you're saying about the oceans absorbing the CO2, and of course with the kind of runaway greenhouse effect, that's heating the planet. So any water is going
exactly
anyway, so it's actually just making the whole situation worse.
Exactly, and it finally reached equilibrium when the temperature was about 480 degrees centigrade. Otherwise, Venus should be about like 40 degrees, 50 degrees or so. So habitable, definitely, but nowadays, definitely not. And this sulfuric acid from the cloud, it actually rains down, but it never reaches the surface because the temperature is so high. So it evaporates before it actually reaches the surface. So we have this convection of sulfuric acid rain in the atmosphere. Not very nice.
So this yellow hue that you were talking about earlier, if you would just have like a normal telescope at home and you would point it towards Venus, would you easily be able to see this with just a normal telescope?
Yeah, so fortunately I have a telescope and I've done it multiple times. I do it every time we have Venus in the sky, obviously.
Yeah.
But so through the telescope, it's sort of yellow-whitish. Okay. It's mostly whitish to the unaided eye, but you can see this yellowish hue definitely easily through a telescope, even with the naked eye when it's high in the sky and not twinkling all that much when it's low in the sky. Okay. So yeah, you can see evidence of it, definitely. Venus also has these strange type of volcanoes that kind of look like pancakes from above. So yeah, we don't really know how they came to be. And some of these volcanoes are really big. The lava fields are really big. They even have lava tunnels there. And so yeah.
And Venus, apparently pancake volcanoes.
And pancake volcanoes, yeah. So Venus, they are sort of like a shield volcano in many ways.
Yeah.
And they sometimes show evidence of some caldera. So you would definitely do a lava show on
Venus.
Okay, cool. Right. Yeah. Okay, moving on. Well, Earth, I think we all know that.
You definitely know more about volcanic activity on the Earth than I do.
Maybe just one question about Earth.
Yes.
What is your favorite volcano on planet Earth?
Volcano on planet Earth. That's a very good question. So I have to, well, obviously I'm a bit biased living here, but...
Aren't we all?
Aren't we all, yeah. But Öræfajökull is just so beautiful. And it's just so majestic in many ways.
Yeah.
And it kind of looks so big when you're in its slopes, driving past it or whatever. And
it's imposing.
Yeah, it is, definitely. And I really hope that one day I will be able to see it erupt. Not that afraid of it. I mean, we are a technological civilization nowadays, so it wouldn't be, well, who knows? Let's hope for the best.
No, but I gotta say, I think that a lot of people who are very much into volcanology and geology share this notion with you. Like, it's this sort of like almost a forbidden kind of wish. Like, you wish to see it, but you also don't wish anyone to get hurt.
Exactly.
But you would love to be able to see it still.
And also its history of devastating this whole area, making it inhabitable for like 2 centuries or so.
Yes.
But and that's probably my favorite. Also because of this mystery surrounding it. Because when the eruption took place in 1364 or something, 1362, thank you. I mean, we don't really find much of an evidence that people were actually killed.
Yeah.
So they must have felt some tremors beforehand and maybe fled before.
There was about 5 people in Iceland at the time anyway. So.
Yeah, well, that's true. Yeah, they may have been swept out in the... Yeah. But there's also part of the mystery surrounding Öræfajökull is this outlet glacier called Kvíárjökull. It has these beautiful moraines, really big, the biggest moraines in Iceland. And it almost looks like something has exploded in the mountain. Just one side of it has completely exploded, and that's actually one of these hypotheses that it actually happened.
A bit like Mount St. Helens kind of thing.
Exactly. Yeah, it has this huge creek or crack in it, or an opening gap, and it just it can't be only the glacier.
No, I mean, I think it could very well have happened, and I mean, I do share your. I think that Öræfajökull is one of the most interesting volcanoes, not only in Iceland but also on Earth.
Yeah.
And I mean, we do cover it, or at least the 1362 eruption at Lava Show, where we tell a little bit about that story. So, yeah.
And you can still see the evidence. I mean, if you drive past it, still see this whitish tephra lying around. So
totally.
Yeah.
Yep.
Actually, worth saying that at some point in the future, we're going to end up doing shows, podcasts rather, where we'll be kind of just talking specifically on like one volcano.
Yep.
We haven't really done that yet, but that's definitely what we will be doing at some point.
We want to focus on like each of the main major volcanoes. And just like, hey, let's get an expert in that just specializes on that one. Yeah.
So it's a little teaser for the future.
Yeah. Teaser. Stay tuned.
Yes.
Hit that follow button.
Yeah.
All right, we've done the Earth, or Iceland, which is basically the same thing.
Basically the same place, yeah. Exactly.
Mars?
Mars is our favorite planet, definitely. It has numerous volcanoes, and interestingly, because we skipped one place, we skipped the moon, because the moon also has volcanoes, and we even have some evidence that it might have erupted within the last 10 or 100 million years.
The moon?
The moon.
The Earth's moon?
Earth's moon.
The moon.
The moon, our own moon, yeah. I don't know how good of an evidence it is, but at least it's based on crater counting, and it shows some evidence that it may have recent volcanism. But, I mean, I'm not the expert there. But still, in Apollo 17, of course, they came across this orangey material on the moon, which was evidence of volcanic eruptions on the moon. And volcanic eruptions on the moon would have been extremely impressive, because you have no air surrounding it, and also weak gravity field.
Yeah,
so the gas is just really high and just falling down, back down in some absolutely majestic way. Probably would love to witness a volcanic eruption on the moon. It would be.
What are the odds that this would ever happen again?
Probably very, very slim. I have no idea, but the moon is so small and it's probably solidified completely. In
by now.
Ways, so highly unlikely. But Mars, so Mars is definitely a volcanic planet. Mars is incredibly Iceland-like in many ways. For example, there's a phenomenon.
It's really expensive there.
Yeah, on Mars. That's right.
That's how its similarities lie. No,
and lots of off-road driving as well. Happening nowadays. But anyway, we have phenomena on the Earth, actually here in Iceland mostly, called pseudocraters, that are also found on Mars. So that's evidence for volcanic activity, of course, and water on Mars.
Yeah.
And we have sealed volcanoes. We have giant calderas. We have even sort of like a tuya, stuff like that.
And I mean the biggest volcano in the solar system.
Exactly. So
Olympus
Mons. Yeah. There's also one other volcano, very ancient, called Alba Patera, which is even bigger in area.
Oh.
But it's much slower than Olympus. So Olympus is around 27 kilometers high or so.
Yeah.
And its caldera on the top of it may be formed of 3 or 4 or 5 calderas actually, and it's roughly the size of Vatnajökull glacier. So it's huge. So even though it's 27 kilometers high, you probably wouldn't notice that you were walking up a volcano, because it's so incredibly smooth and
it's a sealed volcano.
Yeah.
So it's like has a very not a very steep slope.
Yeah,
basically.
Exactly.
Yeah.
So
you mentioned pseudocraters there in reference to water. That is when you've had lava flowing over a moist surface, and it's just kind
of... Yeah, explain that concept for our listeners.
Yeah, it's like if lava flows over wetlands or meadows or shallow lakes, things like that. The water, of course, boils from below, and when it's boiling, it just leads to steam explosions, and it's causing these beautiful formations that kind of look like craters, volcanic craters even, or the craters on the moon, but it's not really proper volcanic crater, but a crater made from steam explosion and water lava interaction.
And we have a lot of...
We haven't, just in the vicinity of Reykjavik. Whenever you drive away from Reykjavik towards the east, you drive past this stunning place called the Rauðhólar, the Red Hills.
Yes.
And they're red because of hematite. Just basically it's oxidized.
It's rusty lava.
Yeah, and if you just walk around there, you're walking around in one of Earth's most unique lava formation in the whole world. So,
I mean, this is literally like 15 minutes drive from the center.
I've just been running around there and go stargazing and whatever. So it's kind of amazing to be in a place like that, which you just in your backyard, really, you have this. So
okay, next.
What's next?
Next is Jupiter.
So next is Jupiter, but we shouldn't probably skip the asteroid belt.
Oh,
so in the asteroid belt, there is this dwarf planet nowadays called Ceres. We call it Ceres.
So is it dwarfier than Pluto?
Yeah. So it's only about 1,000 kilometers. So exactly, it's actually.
You just say dwarfier.
Yeah, it's a word. I claim hereby that it is a word.
It's almost like 1/3 of the size of Pluto. So it's only about 1,000 kilometers in diameter. So it's very small.
Okay.
But there are salt deposits there, which is also evidence for strange type of volcanic eruptions on Ceres.
Really?
Yeah. And
so you can even have like non-planetary
bodies.
Bodies.
Exactly. Because when they were forming 4.5 billion years ago, they were molten, at least partly, and that should have led to some volcanic eruptions, which is why when we find samples of these asteroids, they're often very similar to basalt, like we find in Iceland.
That's so interesting.
There are evidences of volcanoes in even the asteroid belt, which is kind of interesting.
I did not know that.
No. But there you have it. I don't remember the name of the volcano, Anua something, Mons, like that. Yeah.
Okay.
Well, I can't remember everything, so.
No.
Yeah.
You're doing pretty well.
You're full of information, so it's all good.
Yeah. Well, that's good to hear.
Where were we then? Jupiter.
Jupiter. Yeah. We've also mentioned Jupiter earlier, like Io, obviously, and Europa, where we might have some geothermal areas subsurface or sub-ocean, I guess. But we don't know yet. Of course, we know that Io is very, very volcanically active, constantly changing, and it's a beautiful. You can actually, when you look through a telescope, you can also see where Io is, because Io is distinctively more yellowish than the rest of the moons. So you can see these 4 moons through a telescope.
Probably due to the volcanic activity.
Yeah, exactly, because of sulfuric compounds laying around there. So yeah, it's an interesting place, definitely.
So a little bit non-volcanically connected, but about Jupiter. So my 7-year-old is incredibly fascinated with the solar system and basically the space in general, and volcanoes. So, it's a good mixture.
Absolutely.
And he was telling me, my 7-year-old was telling me the other day that they are constantly discovering more and more moons. Yeah. So I guess that they must be smaller moons that are being discovered this late in the process. Yeah. But can either of them then also have volcanic activity?
Probably not, because those are really small. So Jupiter has I think there are 96 moons or something like that.
Right now.
100.
Right now.
Right now known, yeah, exactly. So they might discover some few more in the coming years. So around 100 moons or so. And most of them are tiny. So they're basically just like rock, mountains orbiting Jupiter in many ways. So Jupiter has these 4 moons, Io, Europa, Ganymede, and Callisto. And the rest is just basically junk orbiting Jupiter.
Okay.
But then you have Saturn, of course. And Saturn has now more than 140 moons, if I remember correctly. And most of them are also tiny. But Saturn has more big moons, though. There are some very, very interesting ones. Yeah, especially one called Titan. So Titan is this biggest moon of Saturn, easily visible as well through a telescope. And it has atmosphere. And we have found evidence of cryovolcanic activity on Titan.
Can you explain
Yes.
what that is?
So cryovolcanoes are basically just like ice volcanoes. So instead of erupting typical lava, they erupt something more like a slush or some, almost like an avalanche, just seeping through. You know this.
What's generating? What's powering that?
Well, just melting within the moon itself. So it's just melting the ice from below, and then it should just increase volume. Pressure reduces, so it just has to go somewhere, which is head up. Yeah, and then you have these formations that kind of look like snowy lava fields. Yeah. And I don't know if you remember these colorful liquids that you bought in some shops.
Like
slushy. Yeah. So it's kind of like that. The lava would be.
How interesting.
Yeah. Probably not as tasty, but still. Yeah.
Again, maybe a weird question, but there is this thing that is called blue lava.
Yeah.
On Earth.
Titanium-rich lava, right?
Yes.
Yeah.
Is there anything like that we know of?
Not that we know of. I think the Earth is the only planet we know of so far that has bluish type of lava. It might be on Io actually, because this bluish lava is also from some sulfuric compounds within the lava itself.
The sulfur burning on the surface.
Yeah, but then of course we're lacking some oxygen on Io, which makes burning a bit more difficult. Yeah. But still, some ionization or something might even happen in the sunlight or stuff like that. So. Okay. Who knows? Well, I just have to go there and check it out.
Yeah, do that.
Yeah, sure. Would love to. And stand on the surface of Io and looking up and see Jupiter shining in the sky would be great.
Ooh.
Yeah. But we've also mentioned one of Saturn's moon called Enceladus. So we don't know if it has volcanic activity, but it definitely, it very likely has some geothermal activity deep within, and it's causing the melting of the ice and some of these geysers forming in the crust on the southern hemisphere. But yeah.
So interesting.
Yeah. Well, I think so. Definitely.
Yeah.
All right. My inner 10-year-old has to ask this question. Sævar.
Yes.
The suspense is killing me.
Are we headed to Uranus?
Does Uranus have volcanic activity?
So Uranus does not have volcanic activity, but it's smelly place, definitely.
Fitting name.
Fitting name, definitely. So yeah, many people pronounce...
Do you feel good now?
I do.
So many people pronounce it Uranus, but I think the proper way to pronounce it is Uranus, or Uranos even. Mm-hmm. That's the name for the god.
In Icelandic we say
Uranus.
Uranus.
Yeah. Anus, yeah. Which is not better, probably.
Probably not.
No, but the Greeks weren't thinking about that, or the Romans when they named their gods. So yeah, but Uranus doesn't have any volcanic activity because Uranus is also a gas planet or an icy planet, maybe. But it has some interesting moons. We haven't found any evidence of any volcanic activity on those, not that I know of. But some are really weird and beautiful. And
really weird and beautiful.
Yes. So there's this moon called Miranda. And I was once Googling Miranda. And much to my demise, or I was so disappointed that all I got was these images of some supermodel instead of the moon Miranda. Because the moon Miranda, I know. I'm kidding. I like those pictures better. No, but Miranda is this really strange moon. It kind of looks like it's been broken apart and then sort of glued back together.
Huh.
Yeah, and somebody has taken some shovel or something like that because it has these enormous cliffs, the biggest cliffs in the solar system.
Wow.
That are 20 kilometers high.
Whoa.
And we have no idea how they were formed. So, yeah, a beautiful moon.
Interesting.
Probably not volcanic activity. Might have been some collision and it just got reformed afterwards. Mm-hmm. Who knows? But yeah, it's a stunning moon. So if people Google it, then Google Miranda moon, not Miranda model.
Since we're on the topic of Googling, I mean, how much time do you spend just, in your spare time, just Googling some astronomical things?
Well, to be honest, not that much.
Oh, really?
Yeah. I like books, to be perfectly honest. Mm-hmm. So I like reading nice books about the solar system or some research on the solar system. But of course, I'm online all day like everyone is nowadays. Mm-hmm. And I'm trying to write something for kids or something for my own website or whatever. Yeah. So, yeah, I'm looking at something interesting. And usually try to go to the peer-reviewed papers, of course.
Yeah.
Because nowadays you can't really trust all that much that's on the internet. Because it either might be...
What? You can't, it's all true.
I know. It might be made by a trash type of large language model, which I just don't trust. Mm-hmm. And then, of course, it might be AI generated, which I definitely do not trust. Yeah. So I try to...
And I guess some of the pictures that you may see online are now just AI generated.
Yeah, and that's the thing. When you have... if it's part of my specialty, I recognize it right away if it's fake or not.
Okay.
Because it's always lacking some details that are not part of nature, basically.
Reality.
Especially true with aurora images. Because if you look at aurora images, they're often way more vibrant than they should be. Yeah. The shapes are way off. And also, the stars in the background are never the real starry night sky. And it's lacking the most common constellations, for example.
Right.
This is a public service. We're just educating people as to what to look out for.
Yeah. Exactly.
Using this AI damn thing.
Yeah. Okay, we're running out of solar system.
Yeah, almost.
So Neptune and Pluto.
Neptune, yeah. So Neptune has a wonderful moon named Triton. And Triton is, it's similar to Pluto in many ways. And we have found evidence of some geyser activity on Triton. So when the sun shines through this thin sheet of ice, and just below this thin sheet of ice is darker material, and it absorbs more warmth from the sun than the ice, of course, does. So it leads to some tiny geysers.
So even this far out, this far away from the sun, the sunlight is still strong enough to have this impact.
That's exactly right. So it's like minus 230 degrees there, but still the sun is powerful enough to shine through these thin sheets of ice and heating up darker material, which causes then geyser activity on Triton.
Isn't the sun amazing?
Nature is definitely amazing.
Yeah.
But that was one of those things that people were really surprised about when we discovered it, because it shouldn't really be active.
No.
But still it's there. So nature has amazing ways.
Very cool.
Yeah.
And Pluto?
Pluto has some evidence of also cryovolcanic activity. Pluto is just stunningly beautiful. So in June, July...
Is that so?
Yes. So prior to 2015, we had no idea really, or all that much idea of what Pluto looked like. But then this space probe called New Horizons flew past it and took amazing images. And one of those images, or some of those images, showed this heart-shaped region on Pluto that completely lacks any craters. So it might be a scar after an impact or something like that, which was then filled up with cryovolcanic activity, basically frozen lava of some sort there. But Pluto has these icy mountains, mountains not made out of rock, but ice, and even glaciers flowing down these icy mountains. So, and they might be like 4 kilometers high or so. And the tops of them are sort of chocolate brown in color because of carbon constantly raining down from space onto them. So yeah, Pluto is an amazing place.
So how underappreciated is poor Pluto?
It is, among the general public, probably very much underappreciated, but among scientists, it's an extremely interesting place. Because Pluto also has 5 moons, more moons than we do. And some of them are tumbling and rotating in a very strange way.
Some of them must be about the size of Pluto itself.
Yeah, there's one called Charon. And Charon or Charon, and that moon is definitely formed after an impact. And currently it's tidally locked to Pluto, which means that it can only be seen from one place on Pluto, one side of Pluto. So it's constantly in the same position in the sky, just orbiting Pluto itself. So yeah, and it also may have some evidence of cryovolcanic activity there. So it's an amazing place, the solar system.
I mean, we've more or less gone over the entire solar system, and I mean, I had no idea that there was this much, some kind of volcanic, or at least, geothermal activity going on.
And that's just our solar system.
That's just our solar system.
Well, basically what you need is interior heat, internal heat, and maybe external heat from the sun, and then you end up with some beautiful chemistry taking place, which forms these amazing formations.
Yeah. So, how do we actually know all this?
Well, fortunately,
it's not like for some of these places that nobody's been there. We haven't.
Exactly.
You can't just kind of.
So we've sent space probes into space. For example, Voyager 1 and Voyager 2 traveled past the outer planets, Jupiter, Saturn, Uranus, and Neptune. And they were equipped with some cameras. And basically everything we know about Uranus and Neptune comes from Voyager 2. And then we had some couple of other spacecrafts orbiting Jupiter and Saturn. And basically our space probes have taught us all this.
But I mean, following on this question, I mean, here on Earth, we still have this huge amount of, I would say, undiscovered information, I think, when it comes to what's happening inside of our planet. I mean, sure, we do know a lot already, and I think that, science is going like very fast when it comes to discoveries. Having said that, there's still a lot of unknowns. And I mean, we are here to explore this stuff.
Absolutely.
How can you, just based on pictures taken from space, essentially, when like it's flying past the planet, how can you get that much information?
So the answer is maybe twofold. First, we of course compare to our own planet. We see similar formation on the Earth as we see on planets in the solar system, and we see evidence of lava fields lying around these ancient volcanoes on Mercury or Venus or whatever. And then, of course, we're also equipped with spectrometers. Spectrometers are amazing magic type of equipment because it allows us to chemically analyze stuff without ever even going there. Because everything reflects some sunlight and leaves behind this unique footprint or fingerprint. And just based on that, we can figure out everything.
This is very similar to what we were talking about in the previous episode with Philip Ringrose and Chloe, when we were talking about satellite detection of CO2.
Yeah.
And the same kind of principle. It's like stuff being beamed down, reflected back. So basically the kind of...
That's exactly right. We just expand our senses. And
that's so interesting.
Yeah,
wow.
That's how we discover these things. So, we know quite a lot, but we have so many other mysteries.
Yeah.
So, I mean, aside from it just being interesting to know this stuff, I mean, how does it actually benefit us? Like, why do we care?
Why do we care? Well, it's interesting to begin with, and it teaches us something about our own planet. I mean, probably the most important thing it has taught us is that Earth is amazingly unique. Of all the planets in the solar system, there is a reason we are here and not somewhere else. And nobody is somewhere else than the Earth.
Not yet.
Not yet. At least maybe in another solar system. Who knows? But yeah, it teaches us about the uniqueness of the Earth and teaches us about past climate catastrophes, for example. How little we need to do to actually completely change how our planet looks like. It also just teaches us about...
Don't be Venus, is what you're saying.
No, exactly. Don't. There's an excellent place there to serve as this warning sign to us, shining in the sky even. But teaching us about our own planet, about how we came to be. I think that's a reason enough. But also, the number one reason for me is just be curious about the nature around you. And it also, how does it benefit us? Well, whenever you send a space probe into the solar system, you have to expand technology, and it will be of good use to you afterwards sometimes. So
there's always a lot of innovation involved with every single new expedition.
Absolutely.
Yeah, which then sort of trickles out into other aspects of life, I guess.
That's right. Yeah, I mean, even stuff geologists nowadays use on the Earth was maybe first developed for some space probe because everything needs to be very small. Like, for example, these X-ray machines that you can take samples of rock and figure out what it's made out of. So usually they were quite big, like refrigerator-sized, and we want them to be on Mars, for example, in the Mars rovers. So they had to be shrunk down, take as little space as possible, and nowadays geologists use it in the field.
Yeah. I mean, it's the same with satellites. I mean, their initial purpose wasn't to be able to analyze geological data.
No.
But now that's what we're using them for, and plenty of other stuff.
Exactly.
Yeah. Okay. Cool.
So, for you personally,
yes,
not just as a scientist, but as an Icelander, and also just as a human being, how do you feel about volcanoes and volcanic activity? Like, do they speak to us as humans in a particular way?
Most definitely. I mean, I don't fear volcanoes because we have already experienced quite impressive volcanic eruptions in our lifetime. I know that they can be way bigger, of course, and have much more of an effect, but you kind of learn how to make the most of them, to sort of, what's the word I'm looking for? So to just enjoy them from a distance. And I mean, they heat up our houses, and for me personally, they're just stunningly beautiful, and volcanic eruptions are just hugely impressive. And I don't fear them, and I think they're wonderful, to be honest. We wouldn't be here without volcanoes.
No. So, and we've covered that. I mean, I think that also, yes, there is, like, a lot of people fear volcanoes.
Yeah.
Most of us who live in Iceland don't, I think, otherwise we probably wouldn't be here.
No, sure.
But I do think that there's this sort of primal aspect of our admiration for volcanoes. Like, we know they're scary, but still there's like a pull that, at least for those of us who are fascinated with them.
Yeah, and the thing is, like when the eruption started in 2021.
The one in Fagradalsfjall, Geldingadalur.
So that was amazing eruption because it was so calm in many ways. But walking all the way up towards it, feel the warmth, feel the smell and everything. You're basically just witnessing the creation of the Earth.
Yeah.
And it's the best father and son trip I've ever had. Was taking who was then 11 years old, on a hike for 3 or 4 or 5 hours.
Yeah.
And it's the first time we just spoke about everything. And he was completely in awe with what he saw.
It was a completely awe-inspiring experience.
Absolutely the best.
And I mean, the thing about it also, it was so conveniently positioned, almost like in this circular valley. Yeah. So it sort of felt like an auditorium of sorts.
Yes.
Like almost like a coliseum, if you will, like where you could just sit on a slope and everyone could see. It was like ridiculous.
Yeah, and then you have these hugely impressive subglacial volcanoes because the ash plume is so incredibly big and you're kind of scared about looking at it. But still, you're just fascinated.
Yeah,
I want to go as close as I can to see it, just to experience it. And that's probably one personal thing that I don't like the authorities closing down everything whenever there's an eruption happening. Yeah. Especially for kids, it's nature's greatest laboratory, and it's the best way to get kids excited about science. To go, I mean, we know how to. We don't go all the way up to it. Yeah. I mean, that's a stupid thing to do, like some people actually do.
But some people actually do.
Yeah, stay a little.
Don't walk on lava. Just putting it out there.
Exactly. Stay safe distance away, and it's fine. Yeah. So yeah.
Yeah, but I think even if there have been instances of the authorities here closing out the eruption sites, I still feel like the Icelandic authorities are still more lenient than most.
Oh heavens, yes.
Yeah.
Yeah, well, we don't always need a babysitter. So.
No. But then again, if there is no volcanic eruption taking place, or if the area is prohibited, you can always come to Lausio.
Oh,
that's exactly right. Yeah.
Provo.
Yeah.
All right.
Well done.
Thank you. Just waiting to get that in there now.
That was very, very slick. All right. So we are, I think, getting towards the end of things here. We don't want to take up too much of your time. But there is one other big thing, which is kind of tangential to all of this, but still very important to you. And also probably something that's going to interest a lot of people who are listening to this podcast. And that is that there is a big celestial event coming up in the very near future, a solar eclipse that's going to be visible from Iceland.
Yeah.
So can you tell us a little bit about that? When's it happening and what makes it particularly special for Iceland?
Sure thing. Do we have like 3-4 hours more?
No, we don't.
Damn it. Okay. So, total solar eclipse. I don't know if you've witnessed a total solar eclipse.
No.
But it's nature's most awe-inspiring phenomena by far.
More than volcanoes?
More than volcanoes. So, I keep showing this. So, last time we had a total solar eclipse was in 1954. And it was only like 7 years after the Hekla eruption of 1947. And one of the newspapers in Iceland put up the headline, "Nature's greatest spectacle since Hekla erupted." And whenever I show people this, I say, well, volcanoes are impressive, but they are nothing like a total solar eclipse. Because a total solar eclipse is when everything in nature changes. So you can feel the temperature drop, you can feel the wind change, you can see all the lighting around you change. You can hear how nature is responding to it.
Birds stop singing.
Birds, yeah. So even light in nature becomes completely different. It has this. It's the most beautiful twilight of your lifetime, and that's why I say, well, you don't see a total solar eclipse. You experience it because you experience it with all your senses. And seeing one is not enough because you have to see more and more. I have seen 4 so far, and I'm just right about now. I kind of feel like I've started to really appreciate and seen pretty much everything a total solar eclipse has to offer. And I've seen it 4 times, like I said, and I've cried my eyes out every time because it's so incredibly emotional. And the way people react to it, everyone reacts to it in their own individual way, of course. Many people shout, many people cry, many people curse. It leaves no one not affected.
Yeah.
So everyone is affected by this stunning, spectacular sight in the sky. And during totality, you can actually see these solar eruptions taking place. You can see these solar prominences sticking out from the moon. It's just
outside
stunning.
Of the dark circle.
Exactly. Yeah. And it's just absolutely amazing sight. And fortunately, Wednesday, August 12th, 2026, in the afternoon, we are lucky enough to experience a total solar eclipse in the westernmost part of Iceland. So the eclipse starts in the Westfjords, it goes through Snæfellsnes Peninsula, and then ends in Reykjanes Peninsula and over Reykjavik as well. And we only have like 1 minute of totality here in Reykjavik, but the further west you go, you can maybe increase your duration up to maybe 2 minutes, 13 seconds or so just over 2 minutes. And if you haven't seen a total solar eclipse, well, do whatever you can to experience it at least once in your lifetime. Yeah. It's absolutely amazing.
So for
I hope I haven't oversold it.
No. I think that it was very passionate.
Yeah, well, it's just. I mean, next opportunity we will have is 170 years from now. So 2196.
But I mean, you said it yourself, like this is going to be the fourth one or the fifth one.
Well, this will be my fifth one then.
So you would, in a sense, be something that could be called like an eclipse chaser.
I am, yes.
So, for eclipse chasers like yourself,
yes.
What is, like, is there something special about this one?
So living under the path of totality, that's unique. So solar eclipses, they're not very uncommon. They happen somewhere on the Earth, maybe 1.5 or 2 years, somewhere on the Earth. But from any given place on the Earth, on average, there are about like 400 years
between.
Interval. Yeah, so like last time Reykjavik was on the path of totality was in 1433.
Wow.
And next time 2026, and thereafter 2245. So for me personally, just living under the path of totality is completely unique. I will never ever experience it again. And I'm incredibly lucky to be alive at exactly that moment. So I'm going to just be at home. Hopefully, I can live with only seeing the eclipse for 1 minute, although I will definitely regret having not gone somewhere else for the extra minute afterwards. But I know where I'll be on August 2nd, 2027.
It's like the difference between like you traveling to some city somewhere to see your favorite band playing and then actually coming to play in the football pitch down the road.
Yeah, or just in your house, in your garden. I can choose whatever song you would like to play for me. Yes, please. It's like, I mean, inviting the Beatles to your house.
Yeah,
it would be pretty amazing. But it gives you just goosebumps. It's so incredibly hard to describe. And it's something that people just have to experience to really appreciate. People definitely do not know what the fuss is all about and how much of a frenzy it'll be here,
until they've seen it.
And the traffic will probably be very heavy, especially if the whole path isn't clear. But I keep crossing my fingers every day for the whole of Iceland to be completely
fortunately
clear.
It will be summer.
It will be summer,
it's August, so it's not going to be in the middle of winter when we would potentially have snow, making traffic even...
Summer, so the rain will be slightly warmer.
That's why, well, who knows? Well, speaking of the weather, you cannot do anything about the weather, of course. But it's a problem everywhere in the world. You might have clouds wherever you go.
Yeah.
It's unlikely in some places, like in the Sahara Desert, which will have a total solar eclipse on August 2nd, 2027.
And you're going there?
Of course I am. Yeah, for somewhere around 4,
why did I even
6
ask?
minutes of totality. I'm going to Australia in 2028 to chase the next one after that. So
eclipse chaser.
Yes, but it's just so beautiful.
So,
I have to.
For people who are going to experience it, whether they're going to be like traveling to Iceland to experience it or just our locals, what do you need in order to be able to fully experience it?
Okay, so make sure you're within the path of totality. So is this a line along the westernmost part of Iceland, for example, to watch the partial eclipse when the moon is slowly creeping across the surface of the sun. You need solar eclipse glasses. And, well, if any Icelanders are listening to this, they can order their own glasses at solmyrkvagleru.is and support some educational activities about the eclipse. And then, during totality, when totality starts, you take off the glasses and you watch with the naked eye. Otherwise, you'll miss the show. Because the moon is completely blocking the sun, you won't see anything through the eclipse glasses. And then you put them back on as soon as totality has finished.
Okay.
So that's all you have to do. And then I recommend enjoying it with friends and family, and then do something fun afterwards, like throw a barbecue or celebrating or drown your sorrows, who knows?
Yes.
But that's the thing. So
whatever is your preference?
Yeah, exactly. So if the weather isn't good, let's say it's just completely cloudy or very overcast, we will still get like 50% of the experience.
Yeah.
Day will turn into night for a brief moment. And that's something unique that we'll never ever experience again.
Yeah.
Like somebody just dimmed the sun for a brief moment. And you will feel the temperature change and all that stuff and see some incredible light around you. So it won't be awful. It will be incredibly disappointing, definitely, especially when you've seen 4 and you know what the fuss is all about. But if you're experiencing it for the first time, it will still be unique and fun and interesting.
Well, for anyone who might want to travel to Iceland or to the west part of Iceland to experience it, I want to just tell that I have information about the fact that I know that accommodation is fast selling out. So, it might be a good idea to start looking into it soonest.
Yes. You might even just have to go camping in many ways. But if people want to learn more about the eclipse, there's this website called eclipse2026.is, and it has all the information you need about the eclipse in Iceland.
Excellent. And if people want to go online and find out more of what you're doing yourself, and maybe find out more stuff about the eclipse or the other stuff that you're doing, where can they find you?
So I recommend people go or log on to a website called icelandatnight.is. That's my tiny company that I'm trying to sort of form or start. Basically, it's a small startup. And there you find all the information about how to see the northern lights in Iceland, when they will become active, where to go, because it has the cloud cover forecast, and just all the information you need about anything else that might be interesting in the sky to see. So whenever there is an eclipse or some comet or meteor shower or something like that, the information is there. Because not everything you see posted on social media can be seen from every spot on the Earth. Yeah. And we make sure that we're only telling you about stuff you can see from Iceland, but not from Southern
Hemisphere. And if we finally get an eruption on the moon, that'll be on there
definitely.
too.
Definitely. I'll be looking through the telescope and watching it. Keep a keen eye on it, definitely.
Excellent. Sævar, thank you so much for coming in. That was an absolute blast.
Yeah,
I really enjoyed that.
Yes, thank you. Anytime.
So a massive thanks to Sævar for coming and joining us today. That was so much fun.
No, I gotta say, I knew he was full of information, but the amount of stuff that he knows about stuff that isn't even happening on Earth is just like poof.
Whoa. Yeah, that was kind of factual overload almost.
Oh, it's great. No, but the thing is, he's so well known in Iceland, but maybe not as much outside of Iceland. So I was incredibly excited about this, and he did not disappoint.
No, he did not. He delivered in every conceivable way.
Yeah, it was great. That was good.
So we hope you enjoyed it as well. And if you did, do tell your friends, anybody who might be interested in hearing what we're doing here. And of course, we've got all of our socials as well, if you want to find out more.
Yeah, you can follow us on Instagram, TikTok, LinkedIn, basically on most of the social media platforms. It's Lava Show Iceland. And basically, we try our best to educate people about volcanoes and everything that's happening in a hopefully fun way, just like Sævar just did with us. And so, absolutely. Let us know if you liked it. Let us know if there's anyone that you think we should talk to.
Yeah, but we're always open to suggestions for guests, or you can even suggest yourself.
or what you would like to hear about.
Yeah, absolutely. If you've got anything, any topics that you would really like us to cover, we'd love to hear you. So if you just email us, podcast@lavashow.com, then we'll be only too happy to receive any ideas.
For sure. And thank you so much for listening. I hope you enjoyed it.
Indeed. See you next time.
See ya.